So what we're going to look at next in regards to sampling distributions has to do with what are known as sample proportions. And some of the different formulas that we're going to use that are involved with sample proportions have to do with the mean and the standard deviation. So if we're talking about proportions, keep in mind that we're talking about categorical data here. So if we have a simple random sample of some size n, what we know is true about the sampling distribution is that the mean of the sampling distribution of p hat is equal to the population proportion p. So what we would expect to get if we sampled repeatedly, we would expect to get the mean result of our samples to be the same as what the population value is. The standard deviation of the sampling distribution we can simply find by computing the square root of p times 1 minus p over n as long as the 10% condition is met, meaning that as long as your sample size is 10% or less than the population size. And then some other things that we know in regards to sampling distributions in regards to sample proportions is that as the value of n increases, meaning as the sample size increases, the sampling distribution becomes approximately normal. And before you can perform normal calculations, you need to check the following two conditions. One is that n times p is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10. So as long as those two conditions are met, we can say that the sampling distribution is approximately normal. So some different looks at this, and here what you have is the normal curve, and you can see here we have the mean down the center, okay, which is what the value of p is, which is what the sampling, the p hat value would be for the sampling distribution, and then here's the standard deviation in regards to that. But just keep in mind that this can only be considered approximately normal if the two conditions for normality are met. N times p is greater than or equal to 10, n times 1 minus p is also greater than or equal to 10. So an example here says about 75% of young adult internet users watch online videos. Suppose that a sample survey contacted a simple random sample of 1,000 young adult internet users and calculates the proportion p hat in this sample who watch online video. And the question says, what is the mean of the sampling distribution of p hat? So if we know that 75% of the population from 18 to 29 watches online video, then we can assume that the sampling distribution for p hat will be the same value here. So we would say the mean of p hat equals 0.75. Question number 2 says find the standard deviation of the sampling distribution. Check that the 10% condition is met. So for this right here, we're going to use the formula of the square root of p times 1 minus p over n, which when I compute that comes out to be 0.75 times 0.25 over 1,000, which comes out to be roughly about 0.0137. That's the standard deviation, and then checking the 10% condition is what's here at the bottom. So remember that to check the 10% condition, what I would want to do is take the sample size and times it by 10, and when I do that I get 10,000. So we would say here that the condition is met because it's safe to say that there are more than 10,000 young internet users that are from ages 18 to 29. So we can assume that the 10% condition is met there. So for question 3, it says, is the sampling distribution of p hat approximately normal? Check that the normal condition is met. So the normal condition here, remember there's two things we want to check. First we want to check, is n times p greater than or equal to 10? And when we do that, we get 1,000 times 0.75, which is 750. So since that's greater than 10, that's good. And then I also want to check that n times 1 minus p is also greater than or equal to 10. So when I do that, I have 1,000 times 0.25, which equals 250. And since that's also greater than 10, we can assume that the sampling distribution is normal. And then for question 4, if the sample size were 9,000 instead of 1,000, how would this change the sampling distribution of p hat? So just remember that whenever you increase your sample size, which is what we're talking about here, going from 1,000 to 9,000, remember increasing sample sizes decreases variability, and in this case we're measuring variability by standard deviation. So what we would say here is that the sampling distribution would still be normal, because if I did n times p and n times 1 minus p, I would still get values that were greater than or equal to 10. The mean will not change regardless of the sample size, so the mean here will still be 0.75. However, what will change based on changing sample size is the variability, and variability we're measuring by using standard deviation. So if I plug this 9,000 in for n, you'll see here that the standard deviation for that would be a number that's lower than what we got when we did this for, I'm just kind of backing this up, when we did this for a sample size of 1,000. So because the sample size increases, the variability decreases, hence the standard deviation value decreases as well. And then question 5 says, calculate the probability that more than 78% of the 1,000 randomly selected young internet users watch online video. So since I know that the data here, the sampling distribution here, is approximately normal, what I want to calculate first is the z-score for 78%, using the mean and the standard deviation that we got from numbers 1 and 2. I have here 0.78 minus 0.75 divided by 0.013, which comes out to be a z-score of 2.31. And to find what the probability would be that the z-score is greater than 2.31, because you notice here it says more than 78%, I would do the normal CDF of 2.31 to E99, and when I do that I get a probability of 0.0105. So I got about a 1% chance that would occur. So some other things involved with the normal approximation, and a lot of the things that we're going to look at in regards to sample proportions has to do with the sampling distribution, or assuming that the sampling distribution is normal, so that we can use the normal CDF to answer questions like we just did here. So remember that when the sample size is large enough so that n times p and n times 1 minus p are both greater than or equal to 10, then we can assume that the sampling distribution is approximately normal. So the last thing I wanted to kind of walk you through here was a question involving sample proportions in a state plan do conclude type of format. So what we have here is a polling organization asks a simple random sample of 1,500 first-year college students how far away their home is. And it says, suppose that 35% of all first-year students actually attend college within 50 miles of home. What is the probability that the random sample of 1,500 students will give a result within 2 percentage points of this value? So for the state part of this, what we're going to look at here is we want to find the probability that the sample proportion falls between 0.33 and 0.37. So if you take a look at the percentage that was given in the problem, 35%, and if I want to be within 2 percentage points, then I'm looking at being somewhere around from 2 percentage points below the mean, which is 0.33, to 2 percentage points that would be above the mean, and that would be where the 0.37 comes from. So the state part, remember, you're stating what it is that you're trying to answer. So the plan part of this, okay, is we have a simple random sample of 1,500 students from the population, and we know that the p-value for this is 0.35, meaning that 35% of the students attend college within 50 miles of home. And what I want to do here is calculate the mean and the standard deviation. So the mean for the sample of 1,500 would be the same as the population proportion, which is 0.35. However, the standard deviation of the sample of 1,500 I would find by doing the square root of 0.35 times 0.65 divided by 1,500, and when I do that I get a standard deviation of 0.0123, and then here is the normal curve that would go with that mean and standard deviation. So in terms of checking to make sure that the sampling distribution is normal, I'm going to do n times p and n times 1 minus p, and check to make sure that both of those values are greater than 10, which you can see here both of those values are. And then to find what the probability is, I want to know what's the z-score for each one of those values that we stated in the state part of the four-step process. So the z-score for 0.33 comes out to be 1.63. So remember, we're doing 0.33 minus 0.35 divided by 0.0123, That's this here. And then I want to know what's the z-score for 0.37. So that's 0.37 minus 0.35. Once again, divided by point, that should say 0.123 for both of those. And that comes out to be a z-score of positive 1.63. So the normal CDF from negative 1.63 to 1.63 comes out to be roughly 0.8968. So my conclusion for this would be to say that about 90% of the simple random sample of size 1500 will give a result within 2 percentage points of the truth about the population. So that's just a typical 4-step process state plan to conclude problem for a normal approximation involving p-hat. So just some things to keep in mind with the sampling distribution in terms of sample proportions. Remember that the mean of the sampling distribution is the same as the mean of the population distribution. The standard deviation of the sampling distribution we find by using this formula here, as long as the 10% condition is met. And then we can also assume that the sampling distribution is normal if we know that both n times p and n times 1 minus p are greater than or equal to 10.